So my name's Nina Hanzlikova, and I work in Zalando. And it's not quite so. Zalando is. Let me tell you a little bit about ourselves. We are Zalando's. We are Europe's largest online fashion retailer, and we have the small, tiny goal of reimagining fashion for the good of all. Not ambitious at all, clearly. But that's a fairly high-level goal for an engineer. So the way we go about it in engineering is we introduce a thing called radical agility, which largely revolves around autonomy, mastery, and purpose. The outcomes of this really are that teams get to largely decide how the best way to achieve the technological objectives of the company are, and then look after it. So again, that's a fairly lofty kind of, not a very granular thing. So what do we actually do? So I work in Zalando Dublin, and we are the Fashion Insights Center, which we basically build data science applications to understand the fashion world and to understand our customers and to understand where the two intersect. We try to use these findings to actually help us move faster and move better within our business space. And we have a number of projects around it. My own team was working on the understanding what fashion actually means in context of the larger world. So we would look at what does fashion mean to the world around us? What does it mean to Vogue? What does it mean to somebody on Instagram? What does it mean on YouTube? Stuff like that. So we look at basically fashion data from the wider web and try and understand how fashion evolves, the view of fashion evolves across from high fashion to low fashion to somebody on the street who just wants to buy something cool. We aim to provide a lot of these insights as near real-time as possible because fashion is a very fast-moving market, particularly with the advent of Instagram and similar things. Trends can flare up a couple of days ago and be gone within the week. So you need an understanding and you want to be reactive. So as you can see, we care about the up-to-date information, and as developers, we absolutely loved Kafka from the start, particularly KStreams, because they provided a very fast, very fluid way of dealing with a lot of data, massive amounts of data, which we're trying to get as close to now as possible. So this all sounds wonderful, but much like many things, there's a few caveats along the way. So, as I said, Zalando technology has the goal of radical agility, where there's autonomy, mastery, and purpose. So we can pick the stack that we work with, but we also have to run it, right? Because if Team A picks Kafka, Team B picks Spark, Team C picks whatever else we want, somebody needs to actually keep these services running. We also tend to try and move really fast. So for this, we have adapted very small teams. In fact, my own team was 3 people. We were particularly meant to be focused on delivering customer value, which for us meant getting as good and as up-to-date cross-section of the data we're interested in from the web as possible. And in that world, spending your week troubleshooting an issue with your underlying infrastructure is time wasted. You should. So in our company, we try to have focus on delivering features and customer and business value. So for that, we needed to try and minimize the amount of time we spend on our ops. And this is kind of where my journey for this afternoon will try and take us. When we went, Kafka, it's cool. We really love the stream stuff, right? So how hard can it be to run Kafka, right? Yeah? So that's kind of what we did. We started running our own Kafka. So I guess it makes no sense to really talk about Kafka and KStreams if I don't actually at least do a brief explanation of what the basic components are. So I guess the first thing I should mention is we ran all of this on AWS. which will come into play a little bit later. But what you need to know about Kafka really is there's a ZOOKEEPER and there's Kafka brokers, and Kafka brokers talk to ZOOKEEPER, and producers produce data out to Kafka brokers, consumers consume data off of Kafka brokers. But indeed, there needs to be a bunch of Kafka brokers and a ZOOKEEPER. Formerly, there was a fair bit of configuration data stored in ZOOKEEPER, but more recently, most of the interesting stuff that's stored inside ZOOKEEPER is the controller information for the Kafka brokers. So inside your cluster, there's always a controller, which does a bunch of managerial duties, which is a role. It's not a broker itself. It's a role that can migrate around. And also information about the topics that are stored on your Kafka brokers. And this one is going to be important. So all your topics consist of partitions. They're assigned to different brokers, and ZOOKEEPER knows all about this kind of stuff. It also stores information on where brokers can find each other and broker IDs, what they map to. But again, that's the Kafka topic assignments is the important one. And as I said, we also loved KafkaStreams. So I'll give you a very quick, important cliffhanger note on KafkaStreams. So KafkaStreams at the very basic, if you want to think about them, it's like a consumer and a producer taped together, which manages your offsets in between. It's pretty nice because if I read a message off of Kafka, my processing fails in the middle. I don't have my offset committed, so I'll just reprocess the whole batch. Happy days, don't have to do any of this management. They are more complicated than that. They can do really funky stuff. They don't just do maps and filters. They can also do group bys and aggregations and stuff like that. They're really nice. If you haven't tried them, I highly recommend them. They do a lot of this magic using internal topics inside Kafka. So your Kafka stream will create some management topics for its aggregations, and it will keep a copy of important data in a local RocksDB. So important thing here, there's a RocksDB living inside your Kafka Streams app, or that gets pulled down from Kafka and is stored on your disk and in memory. So with that, let's see how our journey with running our own Kafka went. The fire is only slightly fictional. So we, as I mentioned, run our service on AWS. So there's a couple of things to know about AWS. One of them is that our apps, so our producers and consumers, can shut down anytime because AWS decides to shoot them in the head. This can also happen to our brokers. Brokers are not staying around. They could be shut down. They can be shut down. They can be shot in the head. Network is not perfect. Network partitions happen, so you should expect them. They happen more often than you'd think. And network saturation is also a thing. This also happens. Sometimes network saturation effectively looks like network partition. So network saturation being when I flood my network with messages, so I can't send more data. So some consumers here start going, where the hell's our data? Some producers here go, brokers don't seem to be around. Brokers go to each other, yo, where have you been? And ZOOKEEPER's going like, oh, I haven't seen these guys in ages, right? So it's all very fun. So our basic initial setup was we started with 3 ZOOKEEPER nodes at T2 large instances, which was not a great idea. In fairness, we should really have had 5 nodes. It would have given us a little bit more breathing room in case something went wrong. Also, T2 instances are not great because of their limits. So if their limits on AWS are a little not very forgiving, so they'll work grand until they stop working on you. And trying to debug when you start getting limited on your instances is quite a lot of fun. But everybody starts somewhere, right? So we started with 3 ZOOKEEPER nodes at T2 largest. Probably you'd want to use one of the M family. but you also probably want to keep a little money fire under your desk going with, if you're just using it for Kafka. So it's a trade-off, really. For the Kafka brokers themselves, we use the memory-optimized instances with EBS volumes attached. That seemed to be grand. And for basic properties for Kafka, we switched off unclean leader election, basically to try and avoid a bit of split brain going on. Similarly, we require minimum in sync replicas too, so that hopefully stuff will be persisted if something dies in the middle of writing. And we set our default replication factor to 3 so that we have more than one copy of our data, which is kind of nice. And for producers, because we cared less about throughput, more about persisting the actual data, we set axe to all. And we kind of went from there. There was also some basic stuff we wanted to monitor because, seeing stuff is kind of nice. Managers love dashboards. Pro tip. So we started looking at our disk usage for obvious reasons, because it's pretty bad if we run out of disk. We also started monitoring whether any of our partitions were offline or under-replicated. And that's basically, when I said we had 3 replicas, if a broker has under-replicated partitions, that means not all of its partitions are actually caught up on all the brokers, right? Similarly, for offline partitions, that's basically if there isn't 2 copies caught up in this one. So we monitored that. And also, we were kind of interested in some of the network stuff, because like I say, networks can be fun. So we started basically just sanity checks, seeing how many bytes in and out we were sending, requests and messages. So there, everything is pretty hunky-dory. So, things are never that simple, are they? So, what happens if your Kafka can't talk to ZOOKEEPER? So, fun days. So, as I said before, ZOOKEEPER used to be used a lot more heavily, but nowadays it's largely for some configuration information. So, for a little while, stuff keeps working all right, unless unless your brokers need to do something that accesses ZOOKEEPER, such as get a new, get a new controller. The controller role has to migrate, or you want to change your topic partition assignments, or you create a topic or delete a topic, right? Now, so you can, everything can look grand for days, until one day, the universe aligns in just the right way, and you suddenly realize that your brokers can't actually talk to ZOOKEEPER. And they go, what the hell, we can't live like this. They throw the brown M&Ms out of the window, have a diva moment, and leave you alone. So the moral of the story is, if you have ZOOKEEPER connectivity issues, you might not notice them when they happen. You might notice them days, weeks later. So, but connectivity fixes itself, yeah? Yeah, not so much necessarily. If anybody was at the really interesting morning talk about Kafka on Kubernetes, this issue was touched on there as well. But Kafka brokers use ZOOKEEPER client to talk to ZOOKEEPER. ZOOKEEPER client has a rather interesting little issue which which ate about a week of my life I will never get back, where I ended up reading ZOOKEEPER code and trying to parse what was happening there, where it was caching, it was programmatically caching basically the host, the ZOOKEEPER hosts. On AWS, this is even slightly more amusing, because the way we run our ZOOKEEPER, we have a load balancer in front. Load balancer actually has instances. So our ZOOKEEPER client wasn't even caching ZOOKEEPER old nodes. It was caching the load balancer nodes, which were then being forwarded through to ZOOKEEPer. Inside your AWS, your load balancer nodes are kind of transparent to you. They can scale up and down a lot more transparently than ZOOKEEPer. So when we were checking this issue, we didn't actually even see that any of our ZOOKEEPer nodes went anywhere. They were still there. It was the load balancer nodes which disappeared, at which point we were trying to track a mystery IP address that seemed to be propagating in the logs but never existed inside our AWS account. So watch out for that one. Now, the good news is there are PRs to resolve this issue. They're actually linked when the slides go out. They have been around for about a year and a half, 2 years. So any day now. Yeah, so yeah, there's the ZOOKEEPER caching issue. But like if your network heals itself, I'm sure everything will be grand, right? Sometimes. So we found ourselves on sometimes healing from these kind of issues where our brokers seem to be grand. And then we tried to, again, modify something like delete topics. And suddenly our brokers would start complaining about old ZOOKEEPER version. This was quite baffling to us, particularly when deleting a topic would stuck in the middle. Start getting stuck more and more. You know that tightening feeling in your throat that you get as you're running your services and they seem to be dying in an unpredictable way. And you're picturing your future children being embarrassed to ever know you because everything has exploded on you. Well, this turns out to have been an issue with the way the controller role sometimes stepped down or failed to step down, where a broker, after stepping down as a controller, may not have flashed messages correctly, so would still think that they're the controller. So they would be conflicting. There would be two pseudo-controller roles in your cluster. Now, the good news is this has the fix for this bug has actually been merged in. So, according to the issue tracker, as of 1.1.0. So, if you're running on an older broker, might be a good idea to update. You could spend your better days tracking down these issues, going through various issue trackers, through Git commits, through the entire code bases. In some cases, when you're a small team of 3 people who are trying to deliver business value and you want to recover your cluster as quickly as possible, it's easier to try and basically recover the issue and then delve into it, what was the underlying root cause to get rid of it. So for most of these problems, actually the simplest and fastest thing to do was to restart the broker. It is a little bit of the, shall we say, an unsubtle solution, much like an explosion. Let's torch this place and start again. Now restart, but sometimes you end up making these trade-offs for better or worse. So in most of these problems, we ended up restarting the broker in question. So in our setup, we had an EBS attached which persists the data, but our EBSs, as was default in our company, were set up to actually wipe the EBS volume. So in general, if the rest of the cluster is healthy and grand, a new broker comes in, it comes in with the same ID, the cluster notice and sees, oh, you don't have all the data, they stream all the replica data onto the new broker, and when it's caught up, it joins everything, and everything's grand. So, or kind of. As we ran for a wee while and we accreted more and more data, all of a sudden we realized that when you bring up the new broker, all the other brokers start going like, you need all our data, let's send all of it as fast as we can. So that's when network saturation tended to happen quite a lot. And here you can see a lovely wee graph of as a new replica came up, all basically the request times for all the producers and consumers started spiking up. So it effectively became as if the brokers had an outage going on because nobody could really talk to anybody. This, I should say, thanks to Michalski, one of my colleagues, who did this lovely graph and explained the effects to me initially. So fair play, Michal. But this used to happen. So This was clearly not optimal. Now, there's ways around it. You can actually throttle the rate of replication, but then you need to have a person come to basically run commands against your brokers. So it's not optimal. So what we ended up starting doing was just persisting out ABS volumes. So even if we had to kill our broker, even if we had to shut it down uncleanly, so it had to rebuild its indexes, at least in that time that it was away, there was only a certain amount of data written, so it didn't have to catch up with everything, and it didn't affect the entire cluster once it came back up. What was also really cool about it is it wasn't relying on only a subset of our brokers being down. You would still get you could kill all our brokers, you would get an outage, but the data, when it came back up, would still be there, which was pretty nice. Because, I mean, accidents do happen, and network faults are frequently across multiple brokers. So it was nice to get this little bit of breathing room around the rolling restarts. So that was the basic Kafka brokers, but what about the streams? So as I mentioned, the Kafka streams themselves use RocksDB for local storage by default. And this can, surprise, surprise, this can get quite large if you're doing something more complicated like joins. In general, this can be up to around 200 megabytes per partition. And we had about 90-something partitions. So we were using up quite a lot of our disk. This was also using up, RocksDB does quite a lot of, loads a lot of its stuff into memory. So it was also using up quite a lot of on-heap and off-heap memory. We use the M4 family for our instances, for our Kafka Streams app instances. And we basically keep about half the memory for off-heap usage. And we have an EBS volume attached for all the storage needs for the RocksDB. So if there was one thing we wanted to start monitoring was to basically see the consumer offsets for obvious reasons. If consumer offset is not staying constant, going down when you're producing data, if it's just going up, then that suggests you need more instances or your app has crashed. For this, we messed around with different ways of doing this. We ended up using a tool called Remora, which one of our colleagues, Mark, built. Which is just, it's quite simple. It's a small utility. It repers the consumer describe command. It's pretty nice. It's open sourced. Have fun with it. End of plug. But it did the job. So once again, computers hated us. And we got lovely mystery app failures. So we popped up our Streams app, and it was started working fine. It was getting lovely throughput, and everything was getting processed, and we were happy. We were celebrating. There was streamers flying, people were singing, angels came dancing, all the stuff. And it would run smoothly for a few hours, and then suddenly we started seeing all these errors in our logs about getting locks on file system, that eventually stopped getting locks from file system, CPU spiked, memory spiked, logs just died, app just died, didn't come back. We started, calling the local priest or vicar to give it the last rites. Didn't help. So everything would magically die and grind to a halt. You know those EBS volumes, right? On AWS, there's a thing called IO credits, which are basically kind of self-descriptive in what they mean, but they're a really big thing. So the way AWS kind of abstracts its resources and makes some instances more expensive is through IO credits, which is basically the IO operations onto the disk. So each of your volumes has a certain number of credits as a baseline, which is largely determined by the disk size. So larger the disk, the more you get baseline IO credits. There's also burst balance, and once you eat your allocation, you start eating into your burst balance, and the burst balance and the IO credits refresh over time. So under the hood, our RocksDB was, we had enough space on the EBS volumes to fit it. It was accessing the disk so much that we ate up through all our I/O credits. So once we ate all our burst balance, and AWS went like, no, 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 you don't have enough. We can't let you do this, Dave. We started getting, our RocksDB started getting throttled. The disks became largely unresponsive. Everything slowed down. Stream app and RocksDB, which was expecting the data to be accessible, was going like, oh my God, disk is failing, no! And would die. So sometimes we found, in fact, almost all the time, we found that we needed a significantly larger EBS volume for our Streams apps just to have enough I/O credits to be able to operate than we needed for the actual storage. Fun fact, this also happened with our database, so it's not just a Streams thing, it's EBS volume thing. So we also added a little monitor for checking our EBS burst balance, and you can see quite conclusively how we ate all our EBS burst balance right there. You can get all of these are AWS metrics, you can get them quite easily. So after that, things got better. But things never stay perfect, do they? Particularly, I hope people noticed the pun. I was very proud of myself for the pun. That old beastie, the ZOOKEEPER. So, as I said, Kafka uses ZOOKEEPER to store some coordination info. And the most important of that info is the topic partition assignment. So this would be for, if I have my replica in broker 1, 2, and 3, this would be basically mapping my data is on broker 1, 2, and 3, and 1 is the leader. Yay! And it does it for all the partitions like that. So ZOOKEEPER is a stateful service. So much like Kafka, if you nuke all your instances, they're gone, right? If you're not persisting your data, it's gone. You want to do a rolling update, rolling restart, and be careful about the data persistency. Inside Zalando, most of the services are stateless with a backing store. The ZOOKEEPER appliance itself was developed as a single appliance which inside one auto-scaling group spins up the number of instances, has a couple of managing scripts which help if somebody dies and comes back up, happy days. But in general, in Zalando, most of the stuff we run is stateless services. So during one upgrade of ZOOKEEPER, it so happened that following the internal documentation on how to upgrade instances, all the ZOOKEEPER nodes were killed at the same time. So they started racing on which one's going to shut down first. It was a short race. Then they came back up, but they had not actually copied all the data because they all kind of flapped down. So they had some crazy assignments of five brokers assigned to 3 replication topics, stuff like that. Clearly very corrupted data. So once they came back up, even though the brokers reconnected, nobody knew what data they were actually storing because brokers had the data on the disk, they just didn't know what the data was, right? Because they need to ask ZOOKEEPER, what is this that I'm storing? So all of that information was gone. People weren't too happy about this, so, but you know, it happens. So the good news, the ZOOKEEPER appliance ran under Exhibitor. That's a supervisor system for ZOOKEEPER. It has some backup and restore capabilities. And the Kafka, inside the account, the AWS account, there was a CCore appliance which backs up your topic, which backs up all the messages on your topics into S3. So the bad news, though, is that Exhibitor backups. So inside Exhibitor, most of your nodes are ephemeral nodes, so they change quite a lot. And for that, inside the philosophy of Exhibitor is that you need to actually index the different logs to persist them. And also, if you tear down your entire stack and bring it back up, it's no longer the same cluster. So all of those they're in your S3, but your Zookeeper can't read them. So you can manually start putting stuff together if you want, but good luck to you. Secure for Kafka itself is a last resort recovery solution. And it puts stuff into your S3, but there's no way of actually replaying it. So when it actually came to finding the data, it was there, just nobody knew exactly how to get it out. So we learned some important lessons here. Your backups are really only backups if you can actually use them, right? Otherwise, they're just slightly expensive memorabilia. You should also try and understand what your service means when it talks about backing up, that it actually means what you think it means. You want to test that your backups actually work and that you can replay them, and you want to do this fairly regularly. So ultimately, it wasn't as disastrous as it could have been. We managed to get the original source of the data to replay the data back in, but it did highlight a significant problem with the way we were doing these things. So we basically started looking at our own backups. So we need to persist data when brokers lost connectivity and were shut down. So we got that already with persisting EBSs. We didn't care about KafkaStreams apps not persisting data because they store it all in the Kafka topic. So if your Kafka topic's grand, happy days. We needed Kafka cluster snapshots so that if something untoward happened, so somebody accidentally put the wrong data on a topic, accidentally deleted a topic, we didn't want this to be a catastrophe. And we wanted Zookeeper backups because doing a full Kafka replay takes quite a while and is quite drastic. And your Zookeeper backup, which stores a lot of important information, such as your topic assignments. So for this, we came with a minimalist approach, and we decided to start using Kafka Connect. We thought S3 was a pretty good location for our backups. It's handy, it's fairly cheap. You can go into Glacier if you want. And for that, there's some very handy Kafka connectors. We also needed to be able to play the data out of S3. And now, last time I checked was about 2 weeks ago, but the standard connector did not allow for replay, so we started using a third-party connector, which basically lets us do a full dump of a given topic onto S3 and a full playback back. So we set up a daily cron job to do this, and we regularly test that it actually works back in. For Zookeeper, so we thought a daily snapshot would be grand. It's probably you don't need a daily snapshot, to be honest. That's fairly frequent. Your Zookeeper data really only meaningfully changes when you change your topics. But daily cron job is easy. So we started using a tool called Bury, which is a small open source tool for backing up Zookeeper etcd console, and it lets you dump the data out to S3, Google Cloud Storage, and other stuff, and it also lets you play it back. So it's super simple, it's really nice, and it also works as a nice little cron job. And we also test that this replays our data correctly back out, so we don't actually lose everything. So that would be the very high-level, quick, lots of information out, vomit of words overview of what we ended up doing. It was actually, so I guess the biggest learnings for me from this were that it's great if you can get somebody to run your Kafka at really high, excellent level with all the bells and whistles. But when you're a small team, sometimes you need to basically prioritize what it is your application needs. Is it the throughput or is it the data persistency? What are the important metrics for you to monitor that you'll be really sad if you lose? And also, what is your requirement on data persistency and backup? Is it okay to lose a day? Is it not okay to lose a day? As in a small team, you can still run Kafka effectively if you understand what your requirements are. sometimes you also need to, running on our Kafka, we also found that we needed to understand AWS a little bit better. The underlying components on which all this was running, which as application developers, we wouldn't always be exposed to. And in many cases, our backups and restore solutions didn't have to be super sophisticated, but they had to actually work. So with that, thank you very much for listening, and I hope that was useful.
Thanks, Nina. And you'll have 4 minutes for questions. So, anyone have questions for Nina?
You showed that the ZOOKEEPER was behind an AWS load balancer. What were the benefits of that?
Not great benefits, other than, so it was convenient to run stuff as a single stack within our company existing architecture that we use for our deployment. We largely run most of our services as basically a CloudFormation template, a deployment inside an AWS account. It was largely motivated by giving developers all the control over what they spin up in a compliant, legally compliant manner, because we have some auditing stuff underneath. On the other hand, it does require you to know quite a lot, and it's not a very good fit for all use cases. And I would say ZOOKEEPER is one of those that's not a very good fit. So it's more so, it comes under that if we were doing it again today, or if I managed to get my manager to give me the time to change it, I would very much like to change it.
Okay, thanks.
Anyone else? All right. Well, thank you all for attending, and don't forget to fill out your session surveys. Thanks, Nina.
Thank you.